Hello everybody and welcome to Gilat's Webinar Wednesday. I am Dorit Oren, Director of Product Marketing at Gilat Satellite Networks. I am happy to introduce today's exciting topic, Going Rural with Low OPEX, Small Cell over Satellite. I am pleased to be hosting today Avi Kreiner, Gilat's Director for Cellular Solutions. I will begin today's webinar with a brief introduction of Gilat's satellite networks. We will then jump right into our exciting topic of bringing cellular connectivity to the rural areas. I will first introduce the market potential, the drivers, and the challenges, and then I'll hand off to Avi Kreiner, who will take it from here. He will explain the small cell over satellite solution and how it addresses the rural connectivity challenges. Avi will then go through the evolution, or maybe I should say revolution, in the small cell and satellite technologies, and will show how these changes are leading to a viable business case. Avi will then go on to explain the benefit of an integrated solution, which consists of the small cell on the one hand, and the satellite backhaul on the other. Avi will go on to discuss the benefit of Cell Edge, which is Gilat's solution for the cellular connectivity market. We will then show a brief video that captures the essence of this solution, and we'll close the webinar with our bottom line. At the end, we will take as many questions as time permits, and we'll answer other questions directly later on. Gilat Satellite Networks is a leading global provider of products and services for satellite-based broadband communications. You can see here on this slide that Gilat has a worldwide business and has been around for over 25 years. We have over 1 million products, yes, 1 million products shipped to more than 90 countries throughout the globe. These networks are based on Gilat's VSAT platforms, network hubs, and managed services. These connectivity solutions are provided to many verticals, many markets. To name a few, oil and gas, banking, retail, e-government, and also digital satellite news gathering. Today's webinar will focus on one of the strongest areas where Gilat is involved. Gilat is an undisputed leader in satellite cellular backhauling with substantial expertise in rural regions. As a matter of fact, our vast rural expertise has just awarded Gilat $130 million worth of projects in Colombia and Peru in order to provide broadband services to thousands of remote communities. Another fantastic accomplishment is in Australia. Recently, Gilat completed deployment of 48,000 VSATs for the National Australian Broadband Network, also known as NBN. You can see in this slide in front of you some of the mobile operators with which we are engaged, with over 2,000 sites deployed. I would like now to move on to the market potential. See this chart from GSMA. It shows the subscriber growth rate per region. Look first at the white in the graph. We can see substantial growth rate until 2012 worldwide, primarily saturating the urban population. Then look at the black in the chart. We can see the forecasted growth here until 2017. Now, even though the growth rate is more moderate, the forecast until 2017, it is still quite high in developing countries. GSMA are clearly expecting a huge opportunity for connecting the 1.8 billion unconnected people. See as an example here in the chart, the 8% annual growth expected in sub-Saharan Africa. There are many drivers converging that are now enabling this market. Let's look at the following 4 drivers. First are the new technologies. The evolution of the base station from the traditional large, expensive macro cells to low-cost outdoor small cells is what is providing now a viable business case. Avi will be going deeper into this driver later on in the webinar. The second important driver has to do with government regulations and funding. Bridging the digital divide is on the agenda of more and more governments today. USO/USF is most popular in Latin America. However, we are seeing a start also now in Africa. The third driver is for this market has to do with the outsourcing of network resources. Gilat is actually working with several private companies in Africa, Asia, and South America who are investing in the needed infrastructure directly. They are doing this investment. These companies have a revenue sharing model with the MNOs, which is a way for the MNOs to make additional revenue without big investments. And the fourth driver has to do with remote enterprises such as mining and oil rigs. Here we see examples of small communities that require connectivity and can generate higher ARPU than low-income rural areas. We are seeing two major challenges for the MNOs. First is the feasibility challenge, consisting of the power source and the backhaul. Power is a feasibility challenge since often villages are either located in off-grid areas or simply have an unreliable, inconsistent power source. This, of course, makes it quite challenging to provision quality service. Also, the backhaul is a feasibility challenge. A terrestrial backhaul consists of fiber trenching simply doesn't make sense. The distance and terrain characteristics make this effort way too costly. Another option of the microwave towers is also too expensive, and this is unfeasible in certain areas. For example, in rainforests or hilly terrain. The second challenge that MNOs are facing is the questionable business case. And there are, of course, two concerns here, both the capital expenditure and the operating expenditure. Let's start with CapEx. A traditional three-sector macro cell that often needs a costly tower structure is again simply too expensive for a village of a few thousand people. The cost is not only the cell, but also the required indoor and outdoor equipment needed for the traditional macro base station, which is, by the way, often including cost of a shelter and air conditioning. Additional CapEx also goes to big diesel generators at the sites that are required because of the high power consumption. And now into the OPEX. This is the second business case concern. OPEX is high due to either high electric bills when power is available, or sometimes high fuel costs, which often include dealing with the hassle of fuel logistics. By the way, just as an example, in a discussion recently we had with an MNO in Africa, we learned that they spend $10 million a year on fuel, of which, unfortunately, almost 20% goes to fuel thefts, which is another issue to deal with in this environment. On top of all of this, traditionally, the satellite backhaul has been a very significant operational expense. However, recent developments in satellite technology have dramatically lowered this expense, making satellite backhaul now much more affordable. And this is the topic that will be discussed by Avi.
Hello everybody. As mentioned by Dorit, my name is Avi Kreiner, and I am in charge of the Cellular Solutions product line in Gilat. Indeed, as the header of the slide hints, we truly believe that the small cell combined with satellite backhaul is a game-changing solution in the rural. If until now the cellular operators have reached a certain limit in terms of how deep they go into the rural, now they have a solution which enables them a viable business case even for small villages, even in the most hard-to-reach locations. The solution we're talking about is focusing on three major elements. The first one is the small cell, which is a cost-effective alternative to the traditional macro cell, as mentioned earlier by Dorit. The second one is a satellite backhaul, which offers a cost-effective alternative to other backhaul options, and this is done due to recent development in satellite technology, which I'm going to discuss later in this presentation. And the third one is the power source, which is our case is cost-effective solar system, which is enabled by the special design of the small cell. We designed the small cell, or actually today the small cell is being designed with very low power consumption. So what is a small cell? It's very difficult to define the small cell. It's very difficult to find a single solution or definition for small cell. Everybody has a different view, but the Small Cell Forum defines it as an ecosystem of low-powered 3G or LTE cellular radio access nodes. The small cells were born primarily in order to compensate for the lack of ability of the macro cells in dense urban areas to provide high data rates in the non-line of sight locations and inside buildings. This was the major obstacle which is actually being solved by the small cells. And the small cells are meant to cover these gaps and provide better coverage and capacity for data in order to address what is called by the cellular operators data tsunami, which we're experiencing recently with bandwidth-hungry applications like HD video and streaming and all other bandwidth-hungry applications we see on the cellular networks. As a matter of fact, if we look at the definition of small cell, we can say that there are 4 categories of small cell. The one on the left, top left, is actually the femtocell, which is a very, very small terminal which addresses the residential needs, typically with, let's say, 4 to 8 users maximum, just to handle the household. The second one on the right is the picocell. This is in building, meant usually for, let's say, corporate building or government buildings or malls or any other public areas which require good connectivity for data. The third one is the bottom right, is the metro cell, which is meant for dense urban areas, meaning covering street, covering public areas. And this is actually now, as opposed to the femto and pico, which covering small area, this can cover wider areas of, let's say, a few hundreds of meters, as I said, to cover the streets, to cover some public areas, parks, and whatever. And the fourth one is the one we're going to focus on in this presentation, is what we call the rural microcell, which is actually with typically higher transmit power. And this is meant for covering villages or small towns with a coverage radius of, let's say, up to 3 kilometers. Another interesting aspect is that this new ecosystem actually creates opportunities for new vendors to develop and sell radio access network solutions. We can see Cisco, we can see Samsung, we can see NEC and others providing small cell solutions, and we can also see even smaller players developing solutions for niche markets such as the rural. If we look at the small cell system architecture, what you see is actually that the small cell is another branch in the 3G or LTE architecture. If we look at 3G typical network, we have the node B, which is the cell itself, and then we have the RNC, which is the radio network controller. When it comes to small cells, the node B is actually replaced by a cell which is called a small cell, and the RNC is replaced by a gateway. And as I said before, we can see that actually the gateways are being now manufactured and sold by companies like Cisco, like Samsung, like NEC, and everything is fully standardized by the 3GPP. So this is actually an ecosystem which is really standardized and is worldwide spread. If we look at the evolution of the cellular technology, the basic element of the radio access network is the macro cell. This is how it used to be, and this is also how it is nowadays. It is quite obvious that for the deep rural areas, where ARPU is very low and traffic is not so high, this macro cell is an overkill. in terms of both CAPEX and OPEX, as mentioned by Dorit at the beginning of the presentation, there is no viable business case for macro base station with a diesel generator which requires constant refueling. What you see in the picture is the solution for the rural. This is at least what we see as a solution for the rural. We're talking about a small cell, which of course is significantly cheaper compared to the macro cell. In terms of number of users, it exactly addresses the needs of smaller communities, which do not require hundreds of trunks offered by a macro cell. Typically, 16 to 32 simultaneous calls are definitely sufficient for this environment. In terms of data capacity, this is a small cell designed originally for data handling. Hence, though it's a small cell, it still provides very high data rates. For example, in 3G it can provide up to HSPA+, which is the latest revision of 3G, with data rates of up to 42 megabit per second in the downlink and up to 5 megabit per second or so in the uplink. And of course, it's fully outdoor. The small cell that you can see here, the one for the rural, it's fully outdoor, not requiring any shelter on the ground, again, saving on the CAPEX further. However, the most interesting and important factor is the OPEX related to power when small cell is concerned. If with macro cells, the mobile operators were concerned with refueling of the generators, here they can deploy a cost-effective solar power solution which can last for up to 3 years without maintenance. And in this case, it's incurring no recurring costs. And this is a huge, huge, huge saving in the OPEX. In terms of coverage, if we look at available outdoor small cells, then we're talking about metro cell type of units with several hundreds of meters of coverage. This is the typical one that is being sold in large quantities. The rural small cells are developed. This is actually, as I said, it's some kind of a niche market, we can say, but they are developed with higher power, which can accommodate the remote area requirements of wider coverage than in the cities, which can go up to 3 kilometers radius. If we look at the power, just to go a little bit technical, look at the power. So typical power of the metro cell, which is designed for urban areas, is between 250 milliwatts to 1 watt. And if we look at cells designed for the rural, we're talking about significantly higher power outputs, which are between 2 watt to 5 watt, and sometimes even more than that. Now, let's look at the backhaul. In terms of backhaul for cellular sites, there are several options. This is something you're all familiar with. At the bottom is the most common terrestrial link based on copper or fiber, deployed mainly in urban areas or along main roads, railways, or electric power towers. This is the link terrestrial, which is available in the cities, available in central places. The second one in the middle is the microwave, which requires line of sight, and in many cases in deep rural with hilly terrains or forest areas, it cannot be installed in a cost-effective manner. Gilat has a lot of experience, as I will explain later, in rural development, in rural deployment of networks, and we can see this this can be very challenging in many countries, providing a microwave. The top one is satellite backhaul, is the one we're going to discuss in this presentation. So satellite backhaul actually requires no midway infrastructure, which is actually easier to maintain. And it's often, as I mentioned, with hilly terrains or forests, rainforests, it's often the only option in the rural. So this is actually what we're going to discuss. In the coming slides, I'm going to show you how satellite backhaul is really cost effective and actually makes the viable business case for the rural areas. If we look at the traditional satellite backhaul based on single channel per carrier, or the way it's called SCPC technology, which is deployed typically using C-band space segment with big antennas, we're talking about very, very high capex, both for the modems and the outdoor equipment, which is actually the antenna and the back, or the BUC. SCPC technology requires dedicated bandwidth per site, and on top of that, the veteran C-band space segment with relatively high cost makes the entire solution very expensive. All these parameters keep the lifecycle cost of the solution quite high. Hence, satellite is perceived by many, many mobile operators as a very costly solution. Today, Ku band and even Ka band, for that matter, are being used for satellite broadband connectivity thanks to developments both on the satellite side and the VSAT equipment side. Smaller antennas required by Ku band and Ka band, coupled with TDMA modems, which are significantly cheaper compared to SCPC modems, make the satellite part of the solution much cheaper, especially with a large number of sites deployed, and in this case, even deploying a hub would still keep the cost low. In terms of bandwidth allocation, the TDMA technology is using on-demand operation with a central bandwidth pool, which enables a very efficient allocation of the resources in low-traffic rural environments. If we talk about real development in satellite technology, we're talking about techniques like adaptive coding and modulation, which actually can squeeze many more bits per hertz into the solution. Also, if we're adding the advanced modulation techniques like 32 APSK that Gilat is providing, and we also know that others are providing something similar, we can really get a good business case. In addition, there are voice and data compression techniques which allow to optimize the cellular protocol payload even further than that. Also, one of the most important issues in satellite backhaul performance is, of course, the ability to provide TCP and HTTP acceleration over the satellite delay. And this can be done only by very, very tight integration of the small cell and the satellite product, something which is being done by Gilat, as I will explain later when I will just briefly go over the solution that Gilat is giving. And last but not least, the truly latest word in satellite technology is the high throughput satellite, or the way it's called, HTS. This new technology typically uses Ka band spectrum, but sometimes also Ku band. It is based, as you can see on the right side, you can see the picture of a typical multi-spot beam technology, which is much different than traditional technology. Actually, it is based on frequency reuse, which is very similar to cellular topology, as you're all familiar with. And the way it differs is, if you look at the picture, you can see the circles designating different beams. In the traditional satellite technology, all this area would have been covered by a single beam with a single frequency, and you can now understand the greatness of this new era in satellite technology, which of course translates eventually to much lower bandwidth cost. Okay, we're talking about, if just to give you a ballpark, in normal satellite, we're talking about total bandwidth of the satellite of around, let's say, up to 6 gigabit per second maximum. And with high throughput satellites, multi-spot beam scenarios, we're talking about sometimes about up to even 60 gigabit per second, which is enormously higher than the existing one. Sometimes it's by 10 times the more capacity, and the price is going down accordingly because the price of the satellite does not differ much. Okay, we discussed the small cell. We discussed the satellite backhaul solution. Now let's stop for a minute to discuss the integration between the two. As explained in the previous slide, one of the biggest advantages of TDMA technology is the ability to allocate the bandwidth on demand. This is not straightforward. You cannot just connect two cells You can't just connect a cell to a VSAT and expect it to work. A tight integration is required. This is in order to ensure synchronization between the systems, and features like call admission control, priority of voice over data, priority for signaling, as well as many other parameters which should be taken into consideration when integrating the systems for seamless operation. In addition, for both voice and data solutions, integration is required in order to make sure the allocation of the resources is efficient enough, because the satellite has its own protocol with its own overhead, and the cell has its own overhead and its own payload structure. And it's very important that a good match is going to be done between the two to ensure that the bandwidth is highly efficient. And last but not least, to improve user experience over the satellite, acceleration is required. To develop acceleration over the cellular protocol, again, requires very tight integration with the different nuances which are related to each cell and to each vendor of the cell. So again, integration here is very important, and this is something which is very unique. If you don't have integration between the cell and the VSAT, you cannot achieve the TCP acceleration benefits, and the bandwidth available per user will be much less than even 1 Mbps, actually in the region of half Mbps per user. And the acceleration of TCP enables you to get very, very high bit rates, the same as you're getting in the terrestrial backhaul scenarios. I can assure you that we have full integration and optimization between the two solutions. Again, this is very unique. We're doing constant integration and constant improvements of the features. If we look at the cell, so as I mentioned, the rural small cell is a niche product. Typically, small cells, they have very, very low power output, but here the transmit power is around 5 watt. It's quite high, and it enables connection of cellular mobile phone of up to 3 kilometers in this case. In addition, the unit has been developed specifically for the rural, meaning very, very tight power consumption considerations have been considered, and the consumption, just to give you a ballpark, it's in the region of 30 watts of the cell, which is very low. If we talk about macro cells, we're talking about many hundreds of watts, and actually this enables the implementation of solar power, of low-cost solar power, cost-effective solar power. Okay, another very important feature is the customization of the satellite equipment, of satellite backhaul to the cell. Okay, we're doing all sorts of bandwidth optimization, meaning taking the most efficient voice codec, doing data payload compression, doing packet aggregation techniques, just to make sure that we squeeze the most out of the existing resources. And the last very important issue is, as I mentioned before, is the user experience. We have a very unique solution of embedded TCP acceleration in the product, and this is something which, as I explained, can only be done if you have very, very tight integration of the product, because everybody has very different variant of the protocol, and here we did it specifically to ensure interoperability between the cell and the VSAT. And due to market requirement, we are supporting, actually, as I said, the small cell in 3G and LTE, but we're also supporting 2G solutions where required by the customers. So Gilat has today over 2,000 cellular backhaul sites or installation worldwide. As Dorit mentioned, we have about just over 50 cellular backhaul networks that Gilat installed around the world for mobile operators. One of our things that characterize Gilat is that Gilat has vast experience in rural deployments, Again, as Dorit mentioned, we have operations in Peru, in Colombia. These are specifically rural operations with tens of thousands of sites serving remote communities, remote schools, remote cellular backhaul sites, and so many. So we have, as Gilat, we have a lot of experience ourselves in the rural environment. Also, as Dorit mentioned, we have now experience, very wide experience in Australia with the deployment of 40,000 VSATs for the NBN. What you see in the pictures here is you can see some of our recent deployments in Africa actually. You can see on the left side, you can see people are hanging the small cell on the tower. In the middle, you can see the VSAT and the tower itself. And on the left side, you can see one of the biggest advantages of the small cell is that even if you want to have a high tower, you don't need a big lattice tower like you have in 3-sector big macro base station. You can hang the unit of which weighs only, let's say, 5 kilograms on a very light tower, and of course the cost of this tower, which is combined to the overall low cost, is considerably lower than traditional towers. And the last one is that Gilat is actually very experienced in turnkey installations. We can, if the cellular operator does not want to involve himself in installing the sites, we can also do the installation of towers, the solar power equipment, and everything which is required. This is another aspect of Gilat's experience. Now, just before we conclude, I would like to show you a small clip